.dbf.prj.etc. A multiplier the same root name and different suffixes that stores data's geometry, attributes, projection information, and so on. In order to perform web editing with ArcGIS server, your data must be stored into an ArcGIS data store or in a geodatabase hosted in the Relational Database Management System. The ArcGIS data store is a built-in data repository that comes with the ArcGIS Enterprise. RDBMS is a heavy-duty database used by enterprises to store large amount of data. This includes GIS data, but RDBMS also store many other types of data set. Common RDBMS include Microsoft SQL Server, Oracle, and then open source PostgreSQL. SD also supports a scaled down version of the RDBMS called SQL Server Express that is offered for free by Microsoft. Geodatabases are an XT technology that allows data stored in an RDBMS to easily accessed within ArcGIS. For creating a geodatabase in SQL Server Express, .NET Framework 3.5 is the required component of the database server. With the .NET Framework installed, proceed to install SQL Server Express. To create an enterprise geodatabase in SQL Server Express, we will need to provide a key code file. After installing our underlying RDBMS or SQL Server Express, our key code file, which will be used to authorize the database and the required system components, we can proceed to create an enterprise geodatabase. How to design a map for web editing. Prepare the data, add feature classes to a database, connect to the ArcGIS server, sample data, connect to the database as the data owner, copy data to your database, grant privileges on the data, author a map document to support feature services and web editing, connect to the database as a data editor, register the database with the server to provide register the database with the server. To publish the ArcGIS server, we must create a publisher connection to our GIS server and register your database with it. Add data to the map and set the properties. Publish a map service with feature access enabled and consume the feature services in web application. Next is the GIS server performance and rasterized map tiles. There are various ways to serve maps and the role of tile services. In ArcGIS server, a dynamic map service is drawn dynamically or on demand by the server. Dynamic map services are the default that default that we get when we publish a map service to the ArcGIS server. The OGC or the Open Geospatial Consortium Web Map Service also uses the approach for sending back a dynamically drawn based on URL parameters sent from the requesting computer. Dynamic map services are easy to set up, but they are not the fastest or most scalable type of reverse. Scalability refers to how many clients can be served at one time. ArcGIS server map services can be optionally be drawn as the client side graphics. OGC web feature services are also designed to be queried and drawn by the client machine. Client-side graphics are great for providing interactivity to web applications. Once you get all the geometry and attributes of the features into the client machine, you don't have to go back to the server anymore. You can change the shape or color of a feature in real-time scenario, allowing for the highlighting of features. In tiled or cached map service, the server just hands out little square images or tiles to the map that is stored in a cache or disk. These images are usually generated by the server administrator at a number of different scales. A server can send out tiles a lot faster than it can draw maps. Therefore, the tiled map services are quicker and can accommodate a lot of more users than the other two types of services, that is web feature service and web map service. There are two main types of tiles commonly used in web maps today: vector tiles and raster tiles. Rasterized tiles are easy for clients to draw because most apps and all web browsers know how to manage display an image like JPG or PNG, etc. For vector tiles contain vector coordinates and displayed as the client-side graphics. So the client software needs to understand what a vector tile is and how to deal with it. So what is Open Geospatial Consortium? It is an international voluntary organization origin 1994, and here more than 500 commercial, governmental, non-profit and research organizations collaborate in a consensus process encouraging development and implementation of open standards for geospatial content and services, sensor, web and internet of things, GIS data processing and data sharing. So this is the relationship between the client server and the OGC protocols. So the web browser, web server, and the world viewer. Over open layers JavaScript maps, and it is connected to the map viewer, GeoWeb or RSS viewers. RSS is a web feed, really simple syndication. It's a web feed that allows users and applications to access updates to websites in standardized computer readable format. And the Geo server consists of the WMS, WFS, GeoRSS, and KML. And the web browser, the catalog services, GeoNetwork, catalog search, databases, shapefiles, and databases. This is the relationship between client to server and OGC protocols. How to design a map for tiling? There are two cache or not to cache. Choosing scales. These scales represent the snapshots at which users will see your map. These scales represent the snapshots at which web users will see your map. They also tell how long it is going to take to create the cache and which other services for designing a map on tiling. We have to first to cache or not to cache. If the map is going to put strain on the server or take a noticeable amount of time to draw, then you need to consider making a tile cache. Most vector-based maps that give geographic context to a web map contains a lot of layers. And choosing scale, we have to choose the scale very cautiously, and this scale represents the snapshots at which web users will see your map. Larger scales require more tiles to convert the extent to a map. It takes 4 times as many tiles to cache a map at 1:1000 than 1:20,000. And designing a map, create detailed vector-based maps of the type that typically cached persons can grant cartographic challenge. There are some strategies for building large tile caches. Using an existing tile cache creates tiles selectively, optimizing the map drawing speed, increasing computing resources, and building a cache in the cloud. Update an existing There are some strategies for building large tile caches, which includes using an existing tile cache, creating files selectively, optimizing the map drawing speed, increasing the computing resources, building a cache in the cloud. So this RGS Online, Bing Maps, and Google Maps services have built these caches. And creating tiles selectively, creating tiles at small scales isn't a problem because it takes relatively few miles to cover the map. But if you are limited on time or disk space, it pays to be selective amount which tiles you cache at the largest scales. Optimizing the map to faster draw a map dynamically, the faster will create cache tiles. All GIS software has potential tweaks that can be made to increase the performance. Increasing the computer resources, the more computing power you can put behind creating tiles, the faster you can build your cache. CPU and memory restraints are often more of a problem than having enough disk space to store the files. Building a cache in the cloud. Cloud computing can be an attractive environment for building caches because you can access at a higher level of computer. One challenge with building tiles in the cloud is moving them around. First you have to get your data onto the cloud so that your caching software can quickly get it as the tiles are being drawn. Then you have to move the tiles back to their final home. Maintaining and updating a tile cache. Update strategy should affect the decision to make a tile cache, that is focusing cache updates and automating cache updates. There are two approaches for cache updates: generate the entire cache or focus the updates on the place the data has changed. And automatic cache updates, it is common to perform tile cache updates on regular basis, such as every 3 months. Because caching is so resource intensive, many server administrators like to build the updated tiles on a staging server and then copy them to the production server. And see, what is the cache memory? It is a very high speed memory which is used to increase the speed of the CPU. Increase the speed of the processing by providing data of CPU at very high rate. Access the temporary storage that computers processors can retrieve data from easily.